NENOMATICA, where mathematics meets YouTube excellence. Welcome to our math video. Today we're going to solve linear equations following a specific step-by-step algorithm. We'll go through two example problems together. Let's start with our first example. For the first step of our solution, we need to eliminate the fractions by multiplying both sides by the least common denominator. Looking at our fractions, we have denominators of 3 and 7. The least common denominator is 21, so we'll multiply both sides of the equation by 21. In step 2, we'll distribute the 21 to each term in the parentheses. On the left side, we have 21 times m minus 2 over 3 plus 21 times 1. On the right side, we have 21 times 2m over 7. For step 3, let's simplify these fractions. 21 divided by 3 is 7, so we get 7 times m minus 2. And 21 divided by 7 is 3, so we get 3 times 2m, which is 6m. In step 4, we'll distribute the 7 to the terms inside the parentheses. 7 times m is 7m, and 7 times negative 2 is negative 14. For step 5, we'll combine the constant terms on the left side. Negative 14 plus 21 gives us positive 7. In step 6, we'll move all variable terms to one side by subtracting 6m from both sides of the equation. For our final step, we'll isolate the variable by subtracting 7 from both sides of the equation. Let's verify our answer by substituting m equals negative 7 back into the original equation. On the left side, we have negative 7 minus 2 over 3 plus 1. That's negative 9 over 3, which is negative 3, plus 1, which equals negative 2. On the right side, we have 2 times negative 7 over 7, which is negative 14 over 7, which equals negative 2. Since both sides equal negative 2, our answer is correct. Now, let's solve our second example. In our first step, we'll distribute negative 7 to the terms inside the parentheses. Negative 7 times 2 is negative 14, and negative 7 times negative x is positive 7x. For step 2, we'll combine like terms on the left side of the equation. 4x plus 7x gives us 11x. In step 3, we'll move all variable terms to one side by subtracting 3x from both sides. For step 4, we'll move all constant terms to the right side by adding 14 to both sides of the equation. For our final step, we'll divide both sides by 8 to isolate x. Let's verify our answer by substituting x equals 2 back into the original equation. On the left side, we have 4 times 2 minus 7 times open parentheses 2 minus 2 close parentheses. That's 8 minus 7 times 0, which is just 8. On the right side, we have 3 times 2 plus 2, which is 6 plus 2, which equals 8. Since both sides equal 8, our answer is correct. We want to solve for z in the equation, where 4 minus 2z divided by 3 equals 3 over 4 minus 5z over 6. Our first step in solving this equation is to eliminate the fractions by multiplying all terms by a common denominator. Looking at our denominators, we have 3, 4, and 6. The least common multiple of these numbers is 12, so we'll multiply both sides of the equation by 12. Let's distribute 12 to each term. For the left side, 12 divided by 3 is 4, so we get 4 times 4 minus 2z, which is 16 minus 8z. For the right side, 12 times 3/4 is 9, and 12 times 5z over 6 is 10z, so we have 9 minus 10z. Now, we have a simplified equation, 16 minus 8z equals 9 minus 10z. Let's move all terms with z to the right side of the equation and all other terms to the left side. We'll add 8z to both sides. This gives us 16 equals 9 minus 10z plus 8z, which simplifies to 16 equals 9 minus 2z. Next, we'll subtract 9 from both sides. This gives us 16 minus 9 equals negative 2z, which simplifies to 7 equals negative 2z. Finally, we can solve for z by dividing both sides by negative 2. 7 divided by negative 2 equals negative 3.5, or negative 7 halves. So, z equals negative 7 over 2. Now, let's look at a second example. We need to solve for w in the equation 2 times the quantity w plus 3 minus 10 equals 6 times the quantity 32 minus 3w. Let's start by expanding the expressions on both sides of the equation. On the left side, 2 times w plus 3 is 2w plus 6. Then we subtract 10. getting 2w plus 6 minus 10, which simplifies to 2w minus 4. On the right side, 6 times 32 is 192, and 6 times negative 3w is negative 18w. So we have 192 minus 18w. Now, our equation is 2w minus 4 equals 192 minus 18w. Let's move all terms with w to the left side and all other terms to the right side. We'll add 18w to both sides. This gives us 2w plus 18w minus 4 equals 192. Simplifying the left side, we get 20w minus 4 equals 192. Next, we'll add 4 to both sides. This gives us 20w equals 192 plus 4, which is 196. Finally, we can solve for w by dividing both sides by 20. 196 divided by 20 equals 9.8, or 196 over 20, which simplifies to 49 over 5. Therefore, w equals 49 fifths, or 9 4/5. We have the equation 2 times open parenthesis 3x minus 1 close parenthesis minus 3 times open parenthesis x minus 2 close parenthesis equals 2x minus 1. Let's start solving this equation. First, we'll apply the distributive property to expand the expressions in parentheses. Next, let's combine like terms on the left side of the equation. We have 6x minus 3x, which equals 3x, and negative 2 plus 6 equals positive 4. Now, we'll rearrange the equation to isolate the variable. We'll move all terms with x to the left side and all constant terms to the right side. First, let's subtract 2x from both sides to get all x terms on the left. Finally, we'll isolate x by subtracting 4 from both sides of the equation. Let's move on to our second example. We have the equation open parenthesis x squared minus 1 close parenthesis plus open parenthesis x plus 1 close parenthesis. The equation open parenthesis x squared minus 1 close parenthesis plus open parenthesis x plus 1 close parenthesis times open parenthesis x minus 4 close parenthesis equals 0. First, let's recognize that x squared minus 1 can be factored as open parenthesis x minus 1 close parenthesis times open parenthesis x plus 1 close parenthesis. Now we can see that both terms have a common factor of open parenthesis x plus 1 close parenthesis. Let's factor it out. Let's simplify the expression inside the brackets by combining like terms. We have x minus 1 plus x minus 4, which equals 2x minus 5. Now we can use the zero product property, which states that if a product equals 0, then at least one of the factors must be 0. So our equation has two solutions, x equals negative 1 and x equals 5 halves. Let's summarize what we've learned, which states that if a product equals 0, then at least one of the factors must be 0. So our equation has two solutions, x equals negative 1 and x equals 5 halves. Let's summarize what we've learned in this lesson. We've solved two different types of first-degree equations. For the first example, we used distributive property and combined like terms to find a single solution. For the second example, we factored expressions and used the zero product property to find two solutions. Remember to always check your solutions by substituting them back into the original equation. Keep practicing these techniques to become more proficient at solving equations. Welcome to our math tutorial. Today, we're going to learn how to solve linear equations step by step. We'll follow a systematic approach to solve two different example problems. Let's start with our first example. We need to solve the equation 12 minus 5c divided by 5 equals negative 1/10. Let's start by multiplying both sides of the equation by the least common multiple of the denominators. The denominators are 5 and 10, so the least common multiple is 10. We multiply both sides by 10. Now, we simplify the left and right sides. 10 divided by 5 is 2, so we have 2 times 12 minus 5c. On the right side, 10 times negative 1/10 simplifies to negative 1. Next, we distribute the factor of 2 on the left side. 2 times 12 is 24, and 2 times negative 5c is negative 10c. So we get 24 minus 10c equals negative 1. Now, we isolate the variable term by subtracting 24 from both sides. This gives us negative 10, c equals negative 25. To isolate c, we divide both sides by -10. This gives us c equals -25 divided by -10, which simplifies to c equals 25 divided by 10, or c equals 2.5. So our final answer is c equals 5/2, or 2.5. Now, let's solve our second example. 2x minus the quantity x minus 1/3 equals 4x plus 2/3. First, let's multiply all terms by 3 to eliminate the fractions. This gives us 6x minus the quantity x minus 1 equals 4x plus 2. Next, let's expand the left side by distributing the negative sign. We get 6x minus x plus 1 equals 4x plus 2. Now, let's combine like terms on the left side. 6x minus x is 5x, so we have 5x plus 1 equals 4x plus 2. To isolate the variable terms, let's subtract 4x from both sides. This gives us x plus 1 equals 2. Finally, let's isolate x by subtracting 1 from both sides. This gives us x equals 1. So our final answer is x equals 1. Let's look at our example. We need to solve the equation x minus 1/3 minus x minus 2/4 equals x minus 8. First, let's find a common denominator for our fractions. The common denominator for 3 and 4 is 12. Now, we'll rewrite our equation with this common denominator. To get a denominator of 12 for the first fraction, we need to multiply both numerator and denominator by 4. For the second fraction, we multiply by 3. This gives us 4 times x minus 1/12 minus 3 times x minus 2/12 equals x minus 8. Let's simplify the numerators. 4 times x minus 1 equals 4x minus 4. 3 times x minus 2 equals 3x minus 6. Now we can substitute these simplified expressions back into our equation. This gives us 4x minus 4/12 minus 3x minus 6/12 equals x minus 8. Since we now have the same denominator for both fractions, we can combine the numerators. This gives us 4x minus 4 minus 3x plus 6/12 equals x minus 8. Let's simplify the numerator. We have 4x minus 4 minus 3x plus 6, which equals x plus 2. To eliminate the fraction, we'll multiply both sides of the equation by 12. This gives us x plus 2 equals 12 times x minus 8. Now, let's expand the right side of the equation. 12 times x minus 8 equals 12x minus 96. Let's move all terms with x to the left side of the equation. We subtract 12x from both sides, giving us x minus 12x plus 2 equals negative 96. Let's simplify the left side of our equation. X minus 12x equals negative 11x, so we have negative 11x plus 2 equals negative 96. Next, we'll move the constant term on the left to the right side. Subtracting 2 from both sides gives us negative 11x equals negative 98. Finally, we divide both sides by negative 11 to solve for x. This gives us x equals negative 98 divided by negative 11, which equals 98/11. Welcome to this math lesson, where we'll solve a fraction equation step by step. This problem asks us how many units we need to subtract from the numerator of the fraction 17/20 to get a result equal to 3/5. Let's begin by understanding the problem. We have the fraction 17/20, and we need to find how many units to subtract from the numerator to make it equal to 3/5. We can write this as an equation: 17 minus x over 20 equals 3/5. To solve this equation, we'll first use the cross multiplication property. When we have two fractions that are equal to each other, we can cross multiply. We multiply the numerator of the first fraction by the denominator of the second fraction, and set it equal to the product of the denominator of the first fraction and the numerator of the second fraction. Now, let's distribute the 5 on the left side of the equation. This uses the distributive property of multiplication. 5 times 17 minus x equals 5 times 17 minus 5 times x. Let's calculate 5 times 17, which equals 85. And on the right side, 20 times 3 equals 60. So our equation becomes 85 minus 5x equals 60. Now, we want to isolate the term with our variable x. To do this, we'll subtract 85 from both sides of the equation. When we add or subtract the same value from both sides, the equation remains balanced. Subtracting 85 from both sides, we get negative 5x equals 60 minus 85, which is negative 25. Finally, we'll divide both sides by negative 5 to isolate x. When we divide both sides of an equation by the same non-zero value, the equation remains balanced. So, x equals negative 25 divided by negative 5, which is 5. Let's verify our answer by substituting x equals 5 back into the original equation. We have 17 minus 5 over 20 equals 3/5. 17 minus 5 is 12, so we get 12/20 equals 3/5. We can simplify 12/20 by dividing both the numerator and denominator by 4. 12 divided by 4 is 3, and 20 divided by 4 is 5. So we get 3/5 equals 3/5, which is true. This confirms our answer is correct. Let's summarize what we've learned. To solve this type of fraction equation, we used these key steps. First, we set up the equation based on the problem statement. Second, we used cross-multiplication to eliminate the fractions. Third, we distributed and simplified. Fourth, we isolated the variable term. Finally, we solved for x and verified our answer. The answer is that we need to subtract 5 units from the numerator of 17/20 to get 3/5. Welcome to our lesson on verifying solutions to equations. In this video, we'll learn how to determine whether a given value is a solution to an equation by substituting the value into the equation and checking if it makes the equation true. Let's first understand the basic concept. If we have a linear equation in the form ax plus b equals 0, then a potential solution x equals a would satisfy the equation only if, when we substitute this value back into the equation, we get a true statement. In other words, we need to check if a times a plus b equals 0 is true. If it is, then x equals a is a solution. If not, then x equals a is not a solution. This process of substituting a value back into the equation to check if it works is known as verification or checking. Now, let's look at our first example. Check if y equals negative 2 is a solution to the equation 3 times the quantity y plus 1 equals 4y minus 5. Step 1. Let's substitute y equals negative 2 into the left side of the equation. 3 times the quantity negative 2 plus 1. 3 times negative 1 is negative 3. Step 2. Now let's substitute y equals negative 2 into the right side of the equation. 4 times negative 2 minus 5. 4 times negative 2 is negative 8. Negative 8 minus 5 is negative 13. Step 3. Compare the left and right sides. We get negative 3 equals negative 13, which is clearly false. Since the left side does not equal the right side after substitution, y equals negative 2 is not a solution to the equation. Let's look at our second example. Check if x equals 6 is a solution to the equation 2x minus 5 equals 3 times the quantity 1 minus x plus 22. Step 1. Let's substitute x equals 6 into the left side of the equation. 2 times 6 minus 5. 2 times 6 is 12. 12 minus 5 equals 7. Step 2. Now let's substitute x equals 6 into the right side of the equation. 3 times the quantity 1 minus 6 plus 22. 1 minus 6 is negative 5. 3 times negative 5 is negative 15. Negative 15 plus 22 equals 7. Step 3. Compare the left and right sides. We get 7 equals 7, which is true. Since the left side equals the right side after substitution, x equals 6 is indeed a solution to the equation. Let's analyze one more example. Check if y equals 8 is a solution to the equation 3 times the quantity y plus 1 equals 4y minus 5. Step 1. Let's substitute y equals 8 into the left side of the equation. 3 times the quantity 8 plus 1. 3 times 9 is 27. Step 2. Now let's substitute y equals 8 into the right side of the equation. 4 times 8 minus 5. 4 times 8 is 32. 32 minus 5 equals 27. Step 3. Compare the left and right sides. We get 27 equals 27, which is true. Since the left side equals the right side after substitution, y equals 8 is indeed a solution to the equation. Welcome to this video where we'll solve a math problem step by step. Let's work through this algebraic equation to find the value of m. Let's start with our example. We have the equation mx cubed minus open parenthesis 2m minus 1 close parenthesis x equals 5. We're told that x equals -1 is a solution to this equation, and we need to find the value of m. Since we know that x equals -1 is a solution to this equation, we'll substitute this value into the equation. Let's substitute x equals -1 into the original equation. We get m times -1 cubed minus open parenthesis 2m minus 1 close parenthesis times -1 equals 5. Now, let's simplify this expression. First, we calculate -1 cubed, which is -1. So we have m times -1, and then we multiply -1 by what's in the parentheses. Multiplying by -1 will change the signs within the parentheses. So we get -m minus open parenthesis -2m plus 1 close parenthesis equals 5. This simplifies to -m plus 2m minus 1 equals 5. Next, let's combine like terms on the left side of the equation. We have -m plus 2m, which equals m. So the equation becomes m minus 1 equals 5. Finally, to find the value of m, we need to solve this equation. We add 1 to both sides. M minus 1 plus 1 equals 5 plus 1. Therefore, m equals 6. So, the value of m is 6. We can verify this by substituting equals 6. So, the value of m is 6. We can verify this by substituting m equals 6. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.